Hello there, and thanks for joining us today. Today I'm here to give you a presentation on extending with APIs and how you can use APIs inside FME. My name is Kieran O'Donnell. I work as a data integration specialist with Locus here in New Zealand. A little bit about me, my background is in GIS, so you'll notice that a lot of the content that I talk about here today certainly has kind of its roots around GIS. So it might be around spatial data or perhaps the ArcGIS platform as well. But I will promise to try and stay on message today because obviously we are here to talk about APIs and certainly not about GIS. A little bit about Locus. We operate in Australia, New Zealand and worldwide. We've been on the FME journey for over 10 years now, solving any sort of data problems that you may have. And it's been a really exciting journey to be on to see how the platform has evolved, particularly over the last few years. It's been really exciting for me as well. We've got quite a few experts with all of the FME certifications that SAFE awards, so we do offer quite a range of services as an organization. So on the agenda today, or today's attractions, I'm going to start with a brief intro and then dive into maybe what is an API for those of you out there who haven't come across them before, and a little bit about why you might use them. Then I'm going to jump into two quite in-depth examples. I don't like to spend too much time talking and showing PowerPoint slides. I do like to really get our hands in there and show you things inside FME. So that's where we'll spend the bulk of our time today. And then we'll just wrap things up as well, hopefully before I lose your attention entirely. So I found this interesting quote when I was doing a little bit of research for this webinar, and that's every piece of software built today either uses an API or is an API. They really have become an essential element in today's digital economy, and that means that API growth has been increasing at a very explosive pace. Some of you may have used Postman before, so Michael Bettendorf works for them, and obviously I imagine he would know a huge amount about APIs as well. This graph here just shows the rise in publicly available APIs. I imagine that there's a huge amount more out there that can't be found as well. So these are just known ones, and it's really just kind of indicates how much they have grown, which is probably why, 10 years ago you weren't hearing about them. They weren't particularly on the radar in a lot of cases, but pretty much any software you come across today will have an API. Whether you know it or not as well. So I do really think it's a great space to be getting into and to start paying attention to if you haven't already. What is an API? If it's not something you've come across before or you just hear the acronym all the time, API stands for Application Programming Interface, and APIs are essentially used to access data, server software or other applications. Essentially, the way I think of an API is it's kind of like a secure gateway for two systems to talk to one another. So you expose an endpoint as opposed to the actual server. And so it's kind of a different way of being able to access information or perform functions via web requests rather than actually directly accessing a server. So you need to make what's called requests over an API, and then what is returned is known as the response. So over the examples that I show you today, you should get a bit more familiar if you aren't already with requests and response and kind of that looping workflow. Why should you use an API? That is a good question, but I guess some of the kind of the most important use cases that I've come up for using an API is that it really opens a huge amount more doors than you would be able to kind of go through without having an API available. So you may be able to access data or information which might otherwise be unavailable to you or very hard to get your hands on. You can extend upon the standard functionality of platforms and then make a very customized workflow that actually fits the needs that you have. It may not be such a standard thing that there's a tool built in or a particular function that you can actually access via a GUI. You could build automated workflows that pull or push data without the need for any human intervention. Sounds like a classic use case for FME. And you can turn any data that you pull using an API into a format that suits you and your organization's needs, again, using FME too. So just a little bit on the workflow. You'll start with something like a web API, and funnily enough, FME is at the center of everything. So you can build an FME workspace that will actually make the requests and unpack the response. And then as the last part of that step, you can turn that data into any format that you want, obviously using the power of FME's translating abilities. So now I'd just like to take you through one example that I found particularly useful, and I think it's a good introduction to APIs, and it's using the ArcGIS REST API. I've found this API particularly useful for extending upon functionality that is there in FME, but maybe isn't exactly what you need in terms of an automated workflow. So I've found the ArcGIS REST API can actually be used to extend upon what FME already supports natively. So here you can use FME to make calls over the ArcGIS REST API and utilize the most out of ArcGIS services. So in this example, I want to build an example where I use the API to administer my ArcGIS online organization and take stock of what it holds. So today I'm going to just look at two. I'm actually not going to look at users because I've just realized I only have one user to query, which doesn't make a particularly good example. I'm just going to look at the items in an ArcGIS online organization, my own dev account, and then also I'm going to query a feature layer to return the attachments. I'm just going to jump off screen now and jump over to a demo. So hopefully you don't have to stare at me trying to stare at my FME as well. Bear with me just one moment. Okay. All right, so here I have a workflow that I've built up in advance. And that reminds me, actually, for those of you who haven't used ArcGIS Online before, I'll just quickly take you to my ArcGIS account. So ArcGIS Online is a great cloud platform for hosting data, sharing apps, maps, all things GIS. And I'm just going to log into my account here and show you the interface if it's not something you're familiar with already. So this is just a dev subscription to ArcGIS Online, which I can get for free. Obviously, that means that there's not a huge amount of content or complexity inside this organization. But in terms of my content, you'll see that I have some folders, I have different types of items with names and different metadata about them. So the goal I have using an API is to actually query some of this information using the API. So I really like this platform, but one of the frustrations I've had with using it is actually all of this is obviously data stored somewhere, but it's very hard to actually extract that, which is hopefully where APIs come in. Now, inside this workspace which I've built, it's a fairly standard API workflow where I actually use parameters. So parameters are something which I would highly recommend if you don't already use published parameters or private parameters, particularly for things where you need a username or a password, just in terms of securing that, or also using it in multiple places inside the same workspace. So username, and I've used a password typed parameter for my password to ensure that it's hidden from anyone else who opens the workspace as well. Also, if you aren't familiar with custom transformers, I'm sure there's a lot of great content out there for those as well. But I've used custom transformers inside this workspace, one as a point of organizing it so that this workspace doesn't get too large, but also custom transformers are great to build for APIs because there's often a workflow which you need to do on multiple occasions. The first thing in most APIs is to sort of create an authentication loop. And in this case, I need to retrieve a token from ArcGIS Online so that when I make any future requests, it knows that I have the authority to perform that action. So I've actually built a custom transformer, which I've called ArcToken. Inside that, we pass in my username and password parameter. And if we just look inside that custom transformer, it's a fairly simple thing where we start with a creator and we use an HTTP caller to request the token via the ArcGIS REST API. Use the username and password, and then we actually extract the token using the JSON fragmenter, rename and remove the attributes that we no longer need. And out of that, we're going to pass from our output port, we'll pass the token. So if I just run that short part of the workflow, what we should see that comes out of that component is a pretty long string for the token. So that token is obviously secure, and whenever I make a request further on from here, I use that token in order to authenticate with ArcGIS Online so that it knows that that's me logged in to make those requests. So following on from that, I just follow a series of actions to arrive at my end goal, which is to catalog that ArcGIS Online organization. So I make another request, essentially to query myself and determine what my organization ID is. I want to request the total number of items and generate that as an attribute. And then again, I've created another custom transformer, which is going to perform the search function on my own ArcGIS Online organization. So inside this ArcSearch, I pass it the token, obviously. Count is just a start number, which I'll show you shortly. The total number of items that I know I need to request, and then the organization ID so that I'm searching for my own content. So if I go inside ArcSearch, you'll see this workflow is, again, it's quite a small one. And this HTTP caller here performs a search on my ArcGIS Online organization. And basically what it's doing is querying, like inside the GUI, it's just performing a search for all of my content. So, wildcards apparently are not supported. It's going to start querying my organization. So what we're doing in here is essentially just performing the same sort of search. This needs to create a loop in order to search through the results, because the API supports a maximum number of, it supports a maximum number of records at any one time to a query, so that you can't, if you've got an enormous organization, you can't request 10,000 records, because that's going to start to give you some sort of performance issues. Now, if I jump back to my ArcSearch, what you'll see when I run it to here is the result of all of my searches. So each search can find 10 records. So then the next search that I perform, we need to then start with, we need to start 10 records further. So we start at 1 and then we move it to 11, 21, 31, so that we don't query the same records every single time. Now, if you haven't worked with JSON flatteners or list exploders before, this is the way that it unpacks the API response when it's returned in the JSON format. So you need to flatten the JSON and then explode the list, which takes it from a many-to-one relationship to a one-to-one relationship. And what you start to get is an actual structured table, where before we had bulk responses. When I run it through my JSON flattener and my list exploder, we then start to get each individual record. You see there's 66 records here. That's the number of items that was returned when I actually performed that query initially. Now, if the next few steps is just a little bit of cleaning up, I haven't, fully seen this through because it's not a exact use case which I have a client using or anything like that, but what you can arrive at by then exposing attributes, and I've just shown, for example, doing a test filter, you can see I've actually built up the catalog and filtered based on the different types of content I have in this organization. You can see I've got 4 applications, 11 web mapping applications, 8 web maps, all those sorts of things. I haven't exposed all of the attributes. I've just pulled a couple which I thought so very quickly we can turn a GUI into an actual programmatic workflow. So we are requesting the same content programmatically, and I think it helps to think of this as exactly like what you're doing in the GUI of your browser, but FME is just making those same actions to the server and saving you the need to actually do it yourself. I could obviously search all my content in here, start flicking through it, and then you can think of, say, hitting the next page. It's basically like looping through and doing the next search. So it's jumped up to search items 21 to 40. It's really just a way of doing that same thing programmatically. Now, one other example using the ArcGIS REST API is actually getting attachments from an ArcGIS Online feature layer. So it's great, the support that SAFE have built into FME for ArcGIS Online hosted feature services. So if I wanted to add a reader, I could say ArcGIS Online feature service, and I can add in a data set, which be one of those feature layers which I cataloged in the last step. But the ArcGIS Online platform supports attachments against each individual record, and for something like this, that becomes an extremely complicated function to build into software like this, where you may have many attachments related to an individual record stored inside, say, an ArcGIS Online hosted feature service. So it does become very complicated, no matter what kind of support you build in for different formats, to actually build the relationships between data in a single workflow. This is where I think APIs come in, and you can see from this bookmark, this is how we do it. It's not a terribly complex workflow once you start using an API as well. So if I try and read the data from one of my hosted feature layers, which I have in ArcGIS Online, it's just a dummy one I've created, so there's only a couple of different features. And it'll just take a moment, it takes a little while to load from AGO down here in New Zealand. When I was up in the States, it loaded a lot faster. Now, if I open my feature information window, I'll just get rid of the map view because I don't need that right now. Where is it? Oh, sorry, I'm still looking at the last feature that I was working on up here. I actually need to select a record. That makes a lot of sense. I was starting to get a little bit worried. So inside this ArcGIS Online attachment, you see this list, ArcGIS Online attachment. So the way to expose that when you've got an ArcGIS Online feature layer, feature service brought into FME is, of course, you need to say include attachments, and then you see under format attributes, you expose the ArcGIS Online attachment list attributes denoted by the curly braces there. So it's brought in as a list because inside ArcGIS Online, you could have multiple attachments against an individual record. In this case here, I've uploaded some sample data. I think I did this for my colleague once. He's really into cars. So there's a Ferrari image, and then there is a spreadsheet there as well from another demo I was working on one day. So you can see that there's different content types associated against an ArcGIS Online feature layer. So we've got the same image again, and then we've also got a newsletter we wrote too, which is a Word document. So we've all of a sudden taking from one data set in ArcGIS Online, we're taking about 4 different types of data, which can be a bit tricky. So this is why I've used that custom transformer, as I've just used the same arc token, makes my canvas a lot nicer to look at. If you're working in an enterprise environment, you could use that custom transformer yourself as well. What we do is use a feature merger, just a one-to-one relationship, so that every record is assigned the token value, which we generate using the arc token transformer. It gives all of those records the token. I use a list exploder so that we can turn the the many-to-one relationship into a one-to-one relationship, because the next request I'm going to make over the REST API is actually to fetch those attachments using that API. So if we take a look at this, this is what I love about FME is I could parameterize this to make it a lot nicer, but this is the endpoint that refers to that particular layer, which I'm looking at in ArcGIS Online. And then here we use the dynamic values of the attributes so the object ID is obviously the unique identifier for this particular record. And then using the API, you go to attachments, and then the value ID is actually the attachment ID. And then I obviously need to use the token so that when I request this attachment as content, it knows that I actually have permissions to download it. I then use the file name attribute as well, in order to make sure I name the file which I'm going to download. I'm going to download it with the same name that it's actually uploaded with. So you see here, I've got the name of it, it's got an ID, and then it's related to the object ID. So each record each attachment record is unique as well. If we look at my log here, you see it's actually going and requesting the download of those files. And now if I flick over to where I've actually put that out, you can see the files have downloaded. And it's something to be aware of with things like that, doing this programmatically as well, is that that Ferrari image was located twice. So you just do have to be careful about making sure that there is some unique identifier and that you don't overwrite the same image unwillingly. So it's always maybe a good idea to even put path in the name, the unique identifier of that record inside the file name as well, just so that you do get a complete record of it. Cool. As with any REST API API in general as well, it's a good idea to look at the documentation. So this is the way that you find how to create and format these requests. See something like users, groups, and items. I can see how to query content items, things like this. It's really good to just take a look at the documentation and make sure that you understand it as well. So here, if I hit say something like copy item, it'll give you a description and documentation for how you actually need to create these requests. Obviously, we don't have time to go into that today, but documentation is not something that should be skipped. Cool. So just to recap that, you can use FME to access APIs and extend on functions that are not natively supported. An example of that, obviously downloading of attachments, or say querying an ArcGIS online organization. They're quite specific functions, so you don't really expect that to ever be. But by building a workflow that utilizes FME, like being able to request information inside a hosted feature layer and the information about the attachments that are associated to it, you can then use the API to actually really get a lot out of it. So yeah, that also systematically gets information from something like an ArcGIS online organization. And that would be difficult, if not impossible, without actually having an API to turn that into data. Be quite a long manual process. Certainly if you're working with a larger organization than what I have to. API workflows also let you expose information about a system as data. So as soon as you turn it into data that is inside a table rather than inside a GUI, you can actually manipulate it like it's come from a standard data source as well. But the key here, getting data, what we call onto the canvas in FME is the key. So once you can get it into on the canvas and unpack it, you can manipulate it however you want. Okay, I'd like to show you another demo that I've done as well, and this is around real-time transport APIs. Some organizations provide APIs as a way of sharing data. So the rest one that we've looked at is obviously more around, I guess, a system sort of thing, but this is around data. And in this example, I wanted to create a web application which displays some real-time information in Auckland, New Zealand. So I've got things like bus, train, and ferry locations, traffic cameras, and electronic signs. Just bear with me a moment and I'll pop up this next workspace. Okay. I guess probably documentation, as I said, is very important, so I should probably show you first. So I'm going to walk you through two different entities, sort of open data or developer portals, if you like, and their sharing of data via an API. So the first one is Auckland Transport. They've got a really great API here for requesting data. I should probably sign in, that'll help me. So you can see here, if I log into it, there's a few different options for data that I can request. In particular, real-time GTFS information is going to return me essentially, in particular, the vehicle position. So this is going to give me all of the positions of vehicles which are actually out in the field, which I think is pretty cool to be able to share that, considering that there's actually hardware out there on each bus, ferry, or train in the city. To be actually able to share that and give that to me, is just sitting here at home on my MacBook, is pretty impressive, and obviously impossible without something like an API. The other entity the data that we'll look at is New Zealand Transport Agency. So while Auckland Transport is the local I guess authority, New Zealand Transport Agency is more, I guess, what you'd consider a federal or centralised government agency, and they look after things like our state highways, motorways, those more high interest networks as well. So you can see here they've got some different sorts of APIs, and they'll give you different documentation as well. You see they share some data, and there's a link through to Auckland Transport's one, which we've just looked at too. So I'll walk you through the first workflow I've got here, which is around the vehicle positions. I had a lot of help from a colleague on this when I was learning FME a few years ago. Mike Overdrews, he gave me a huge amount of insight into how to actually unpack these, which I'm sure I probably would have struggled with without some of this, some of his insights that he gave. So a huge thanks to him. So you'll see from this already, hopefully you should be picking up a couple of patterns around what's familiar or what's repetitive, no matter what we're looking at. Inside our last workflow, what we always start with is a creator, goes to an HTTP caller, you get some sort of JSON flattener or fragmenter and a list exploder. So kind of, I think what's really helpful with APIs, even though they can be a bit daunting to learn at first, is it's important to remember that the same principles effectively apply no matter which API you're using. You need to format your request and return request information and then unpack the response. And that's what this workflow does. So in this instance, what we're going to do is use an HTTP caller to get our real-time vehicle locations, subscription key. This is bad practice. So do as I say, not as I do. You should be using a parameter inside here, so that if I was to change my key, it would be inside the published parameters as opposed to hard-coded into my transformers. So again, when I request that data, our response is takes a little while to load, but it's a big chunk of text, which looks pretty heinous and pretty daunting if you haven't used it before. But again, as I was saying, the important part is just being able to apply these same skills to actually flatten it and unpack it. So I use a JSON flattener to flatten the response, and then a list exploder to turn the JSON into individual records. So where I had one request return one big chunk of text, I've now exploded that, and I have 1,496 records, which should relate to vehicle positions. Now I have an attribute exposer, so that exposes the attributes which are actually part of the JSON, and tells FME how I actually want to form a table, and then just a bunch of cleanup things and a creation of geometry. So I'll just run it through to here because it'll make a little bit more sense. So here you can see it's unpacked those attributes, and this table, you see things like timestamps, occupancy status, its bearing, its lat long position, be an odometer reading, not odometer, but its speed based on the GPS, labels, license plates, things like that. So quite a rich amount of information from one single request. And then if I turn on my map view, what we should see, there's some stuff worldwide, which we'll touch on later, but the bulk of them located around Auckland, New Zealand. Hopefully all on the road as well. So that's Auckland CBD, Auckland Transport's office is right there, and then the Harbour Bridge. So I am doing this at just after 5, so when I do actually get you an example to show moving real time, maybe things won't be moving so fast, but nevertheless. Now I just do a few things which everyone should be comfortable with using FME. Basically, it's just formatting of attributes. Once you get data onto the canvas and turn it into tabulated records and get that structure, everything else should be applicable in the same way that you do any sort of data flow as well. This here is just formatting some attributes, and that's for the output. Really just around thinking around the user experience, because I wanted to build a map interface. And so turning things like date times and whatnot into meaningful things to an end user is obviously important, and where while pulling from an API is great, and there's a lot of ways that you can pull from an API, actually then turning it into something meaningful is often another story altogether as well. I then just join it to the routes, which I also pull using another API request, do some filtering for Auckland region's boundary. That's around determining ferries, purely just to find out what ferries, what records are ferries, so that I can assign them a mode and symbolize them accordingly. And then as my last step, I actually write those features as GeoJSON and output them to GeoJSON files for each particular route type. So as a fairly quite, what I think is quite a cool case. So unachievable is you've got sensors on all these vehicles, whether they're trains or ferries or buses out in the field, and an entity like Auckland Transport obviously needing to keep track of those, but there's no way that I would be able to get access to this, just as an average member of the public without something like an API. It's really nice that they can actually expose this data to anyone via a secure means as well. So I think that's why it's such a great skill to learn as well and get comfortable with using APIs. Okay, I'll just quickly show you one more API workspace before I show you the final product as well. This is going to be Info Connect Signs. So this is another fairly straightforward workflow. Once again, same recipes. I'm not going to go into this one in as much detail, but the reason I'm showing you this is because it's come from NZTA rather than Auckland Transport, but it's also XML. So the other two APIs that we've looked at so far, both I've returned the data in JSON. This one, it actually, let's run that. I did use parameters in this one, that's good. But what you see in the response body here is actually XML. So even though it's completely different format, the good thing about this is that it's actually exactly the same workflow no matter what. It's the exact same process to turn it into tabular data. So nothing to be afraid of if you then encounter XML instead of JSON as well. So what this one does is it's actually an API which returns the message on electronic signs, which are on motorways around, or state highways around New Zealand. So you can see there's a little bit of formatting to do. Again, another reason why it's great to use FME to then unpack the response from the API, turn it into something which is user-friendly, and then output it to a format, in this case GeoJSON, which your system can then interpret. So I'll quickly, in the last few minutes of this, I'll just show the end product of doing something like this. So I'm just going to start up my FME server. So those API workspaces which we've just looked at are actually being run on my FME server. I published them ahead of time. The vehicle locations one is just running on a very regular schedule so that you can see, so that we can get, I guess, the map to move and you can see the importance of it or how it would actually work. And it only takes 5 seconds to run. So it's a pretty quick update process to actually get that information from an API that Auckland Transport provides and output it to a file which I can then display on a map. Now, I will just open up the app. I have what I'm going to set up here. nothing to worry about, but it's just a way that I set up a kind of like a pseudo HTTP server to get around the cause areas that I normally have to deal with. So simple HTTP server serving on port 8000. That means when I access localhost 8000, what's being served is it's treating this www folder as a as my web server for this local machine. Just if you're wondering, so this index HTML file is just a file which I've used to build this very simple web application using the Mapbox GLJS API, and this references all of the data sources that I've just demonstrated. So we zoom in. As I was saying, it's 5 o'clock, so hopefully things keep moving on us. But you can see hopefully there we go, things are moving. Just had to make sure that it was working. As I always look at the harbour bridge, because hopefully, you know, if there's no red lights on a harbour bridge, so hopefully things should keep moving relatively quickly. I've unpacked all of the information which is being displayed here, and you know, turn it into something user friendly, like turn the timestamp into an actual time here in New Zealand formatting time, and then also done a calculation on when that process is run in FME to the current date timestamp versus when it was actually received, to give you an indication of how many seconds ago. Obviously for something like a real time, it's great having the last ping from a bus, but if that last ping was 613.6 seconds ago, this real-time location is absolutely meaningless to us as well. There's actually a little depot down here, so I think that's why they're so far behind in pings, not really transmitting. Now in here as well, you can see these are the signs which are being, there you go, which we're pulling from the NZTA Info Connect system, so you can get an indication of what signs, what messages are being transmitted on the electronic signs. There's some other things in here I haven't explored today. These are the trains. It's got the bearing to show the direction that it's heading in, getting all that over the API. There's traffic cameras, which we pull from NZTA as well. You can get that over another API as well, so that you can actually see the images on the motorway in real time. Doesn't look like traffic's terrible today, so I'm sure you can't see that at home, but it's actually got a date timestamp up there as well, so you can see how long ago that image was actually updated to. A little search here, which again we used to pull from the API, so we get things like all of the stops, because stops do tend to change. I don't know stop numbers very well, but built a little geocoder into here which updates with all of the different stops being pulled from an API. Here's the ferries with the names of the boats as well. There's all sorts of stuff you can do once you get access to the data as a start point. So it's quite, it's pretty cool to actually get access to data like that, because before APIs it was near impossible to. Cool. It's like my presentations decided to return back right to the start. So just to recap, APIs can expose real-time data to you, which would otherwise be unavailable. Data can be received live rather than relying on like a static data dump, which has always kind of been the way we've done things until APIs really, or services at the very least. And it happens on an infrequent schedule. So something like this is just, it's flat out impossible without actually getting exposed to the data and being exposed to those servers would be impossible unless you're inside the organization too. So by widening the scope of data which can be accessed, you can actually extend the possibilities of what you can create as a result too. So just to conclude, APIs I think are a great way to access data of any type. Building workflows with API extends the possibilities of data integration to be almost limitless as well. There is a learning curve to getting used to APIs, I can admit that for sure. It certainly took me quite a while to wrap my head around them. But just getting a few workflows which have been done in the past to kind of use as a template really helps. So those same principles can be applied to almost any system. It's just the API and the formatting of that request that changes, but actually unpacking it is pretty much the same deal anyway. And although APIs are somewhat of a new phenomenon, they are an essential, I guess, format to be comfortable with going forwards. So I'd recommend giving it a try. There's plenty of publicly available APIs to practice your skills on now. I've shown you a couple today, and I'm sure everyone around the world can find some or have probably seen some that they haven't used and can use as well. Honourable mention to the FME Hub, like anything, FME Hub is always providing some goods in this. So web connections, that's been great for me in terms of being able to get used to APIs. So I find it really useful to use your own data if you're trying to learn a skill like this. So Strava was something that I spent a lot of time on because I'm pretty into my running, and you can actually extract your data using the Strava API. And SAFE have done a great job by building some of these web connections so that it kind of helps you out with that authentication flow to begin with as well. So yeah, that's really great, as well as some API templates you can find on the FME Hub, things like Zendesk. There's all sorts that they've done. So yeah, big ups to the team at SAFE for helping out in that regard too. So thanks for joining me here today. I've had a really good time and hope you've got something from this presentation. And yeah, drop me a line if you've got any questions around APIs. I'm always keen to hear. Cheers.